at Stanford Artificial Intelligence Institute. He actually led the Google core search algorithm group. And fun fact about him is that he taught over 160K students worldwide. So welcome, Senia and Peter. You're tall enough, I'm a little short. Well, Peter, I want to first thank you for this time.
Great to be here, thanks.
We have a lot of grounds to talk all things AI, and I'm excited to dig in. So, why don't we start with painting a picture on the AI research landscape. From an outsider point of view, that field has evolved at warp speed. But you have been there in the earlier days, so paint us a longer picture than the last, say, 2 to 5 years. How has it evolved? What are the challenges? How are they different?
Yeah, so I'm the AI hipster. I was doing it before it was cool. And then in 2023, everybody else discovered it. But it certainly is different. It's evolved over the years. One of the things I got to do is I was in the right place at the right time in 1995 to write a textbook, and then and I've talked to some of the authors of other textbooks, and they all said, oh, well, yours was good enough, so we're not going to do another edition. So I've had to do 4 editions, and so I've tracked how the field has changed. I think, we came along in 95 at a point where there were big changes in the field. So we went from an approach based on expert systems, which meant you went out, you interviewed an expert, you asked them, how do you solve this problem? And then with blood, sweat, and tears of graduate students, you tried to translate that into code and wrote it down. And we realized that didn't work for a couple reasons. One is the experts don't know anything about what they know. They can't really self-report well. And secondly, this idea that you could write everything in code just didn't converge. You got to the point where as you scaled up, there were more errors introduced than there were fixes. And so in around 1990s, there were 2 big changes. One to say, well, we're going to use machine learning. We're going to operate on data rather than on handwritten code. And that was a big advance. And the advent of the web meant there was more data available. And then the second difference was you said, well, we're going to move away from trying to do things with pure logic and move more towards probability. So that happened then. And the next wave was to move to neural nets, which some ways you can interpret them as saying they're acting on probabilities, but they're not really, right? Instead, they're just acting on numeric values that don't strictly conform to the laws of probability, but they allow more flexibility. And if you have enough data, you can take advantage of that flexibility. So that's how we got to where we are today.
Any surprises with the most recent boom in advances, and what would be some key moment that you consider a breakthrough?
Yeah, so I think everybody was surprised. So I knew back 10, 15 years ago that if you wanted a generative model, you could generate text just by training on other text. And you could train character by character, word by word, and have sort of a Markov model, and maybe a few complications. And you could say, generate me a text, and it would be good. But it couldn't answer a question and do all the things that today's generative models could do. So I think nobody really felt like we could get where we are today just by doing that. We thought, you're going to have to code in something. And so it was a big surprise that just having more data was part of it, much faster machines was a really important part of it, and then a few little tweaks with like transformer model and so on to allow for memory that's not just the Markov model of the previous n token. And the transformer model went out, and I think that's great. That came from Google. But I don't think it necessarily had to have been the transformer model. It just had to be something that had this notion of memory and attention, and that's the way it worked out. So I guess we were all surprised that it worked as well as it did without having to put in some kind of knowledge or something, or reasoning. And then the other thing that was surprising to me is, you know, if you told me 10 years earlier, here's an example of what these chatbots can do, I would have said, that's amazing that they're so good. And I also would have said, that's amazing that they're so bad. And I would have thought anything that could do the good things that it could do would never do as many bad things as it does. So that was a surprise to me too. And I think it simultaneously said two things, right? So I knew all along that language is an incredible invention. Probably mankind's greatest invention is written language. And I knew there was a lot there. But I always felt like, yeah, there's a lot on the written page, but that only comes to life when the human brain is observing that, and there's sort of a back and forth between the written page and the thinking process. I think over the last year, we all felt like, yeah, that's still going on, but maybe there's a lot more on the written page than we had expected, and less going on in the thinking process.
I want to come back to the point of surprise and the language a little bit later, but before we get nitty-gritty, I want to get some names out of the way, definition out of the way. The frontier of AI keeps changing. We kind of call the latest thing synonymously with AI. The last 5 years was maybe computer vision and deep learning. Right now, obviously, it's the chatbot, LLM, and Gen AI. All of it kind of live now under the arc of AGI, artificial general intelligence. There's a lot to unpack there. We can get very existential when we talk about AGI. So without going too deep, can we maybe define that for you? Because I know you have a take on what AGI.
Yeah. 3 words. Artificial general intelligence. The artificial part seems pretty easy, and that it says it's something that we built. On the other hand, there's a lot of natural in that artificial part, because it's all built on data that was generated naturally. Second part, general. And so the big change over the last 2-3 years was, you know, I said we started out with expert systems, and then we moved to machine learning systems, but they were still systems that did one specific task. So they were trained to do this one thing, right? So Google, I helped build machine translation systems, speech recognition systems. They did that one thing. And, you know, DeepMind built a system to play Go, and so on. And you didn't expect them to do anything else. But then we got these general systems that did lots of things. And you just train up one model, and then maybe with a little bit of fine-tuning, it can do lots of different tasks. And that was really a first. And to me, that's what general means. And then intelligence is sort of, well, the more the better. And I guess people are, you know, so there's a lot of, nobody can agree on this, on when it's going to happen, in part because it's hard to predict, especially the future, but also in part because nobody agrees on what it actually means. And does it mean sort of intelligence of the average person, or the top few percent of people, or beyond human intelligence? And general, does it mean on several tasks, or on thousands of tasks, or on every task? Nobody can agree on that. So I was reading a book called Proving Grounds, which is about the invention of the ENIAC computer, the first kind of general purpose electronic computer. It was done in the 1940s to compute trajectories for artillery in World War II. And the book was on the programmers for the system, which were all women, because they decided, well, the men are going to do the hard stuff, which is the wiring and the electronics and just the software stuff. That's going to be easy, so we'll let the women do that. Turned out to be not so easy, but they got it done. And that book really struck me, because I said, oh, wait a minute, that was a terrible computer compared to the lowliest Raspberry Pi of today. But it gets credit for being the first general purpose electronic computer, because it had sequencing, looping, and conditionals, and programmed instructions. And that's all you need to be general. And yeah, computers today can do a lot more and can do a lot more things, but in 1945 we had achieved
That was the
general.
milestone.
Right. And so Blaise Aguirre and I wrote this article a couple of months ago saying, we're here for these language models of today. So we said, well, AGI is already achieved today because we have these systems that are general. Now, they're not 100% general. They can't do every task. They're not 100% intelligent. They get lots of things wrong. But the very architecture has changed from one task at a time to being able to do multiple tasks at a time. And so when we say AGI is here, we don't mean we're done, we're at an endpoint. We mean when historians look back 50 years from now, they're going to say this was an important point where we went from single purpose to general.
If I could paraphrase what you said, it's basically the sense of general intelligence. We're already starting there. It's just how far we will go.
And maybe it's, we're anthropomorphizing too much when you say general intelligence. So I would rather want to break it out and say there's one thing which is general capability, that you build a system that can kind of automatically do multiple tasks, including ones you didn't think of when you were designing the system. So that generality. And then there's a second part that we call intelligence, but maybe we should just call it success of how many different problems can it get right versus the ones that get wrong.
So it's not just relatively soon, we already started is kind of your take. So you kind of mentioned a few things there. I want to get a reaction of, do you think we're reacting or learning fast enough, given that we're already kind of opened that milestone?
Yeah, and I think that's a problem with any new technology, that you start applying it, new applications come up, new really useful applications come up. It benefits humankind in many ways, but also negative things can happen. So you look at internal combustion engines. That's been great. It's allowed people to move around. It's allowed food to be transported and solved a lot of hunger problems. But we kill a lot of people in car accidents, and we have a lot of pollution, and that's affecting our climate and health. It probably would have been better if 100 years ago we'd been thinking more about those potential dangers more. So I think we're in a pretty good space for AI because there is a lot of thought for all these potential dangers, both the unintended side effects and the malicious use of the technology by bad actors. And I think we're doing a pretty good job of spending a lot of attention and trying to mitigate those dangers.
You're a big educator, and that includes the implementation of AI, but nowadays a lot at the Stanford HAI, the Human-Centered AI Institute. So how do you see that education going? What are some of your main, I'll use the word concern maybe, around responsible AI and AI ethics and how the conversation is shaped?
Yeah, so it's a huge topic. We could spend all day on that. So I joined this Human-Centered AI Institute at Stanford because I thought that was the right way to think about it. Fei Li, who I've known for many years, formed the Institute and sort of set its charter in place, although she did leave it to me to define both the undergraduate and grad level class on human-centered AI, so I got to do that. To me, I guess what it means is taking into account the effect on people rather than just taking into account your success ratio on some performance metric. And so what does that mean? Well, say if you're building a self-driving car, if you took a traditional AI approach or even a traditional software engineering approach, you say, well, what's the problem? Well, I got to drive accurately along the road, and I want to serve the user, who's the person sitting in the front seat. So we're going to have a nice dashboard display, and they can interact with it and say where they want to go, and so on. And if I've done that, I'm done. The human-centered AI approach says, yeah, you got to do that, but you have to take larger context into account as well. So you're not just serving the person sitting in that seat. There's also, you're interacting with other drivers and pedestrians and so on. You have to take them into account. And then you're having an impact on society in terms of how you change patterns of commuting and pollution and everything else, and you have to take that into account. And thinking about things in those levels of what's the impact on people at every single level, I think that's the main part of this human-centered approach.
That's awesome. I think the framework, the three key pieces that is laid out there, it's the user, the stakeholder, and as well as society. Now that sounds very straightforward, right? Everybody should be framing problems like that when they start, ideally. How do you see implementing that or building incentives into people that are building or private sector that are building so that it's actually a default and they can balance thinking about the three pieces with building with speed, which there's a lot of urgency and pressure these days to get. So.
I think a big part of it is training, which is one reason why I'm interested in focusing on education, and I think that comes at many levels. So within the big companies, you see they all have programs around this. You see that less so in the startups because they're more focused on doing one thing. So I think education comes at multiple levels, so it's internally imposed by the company. There may be sort of professional levels. So everybody's got their sets of AI principles now. There are a dime a dozen. And the companies have them, professional societies have them, the ATM, IEEE, and so on. And I think it'd be good to have more of an emphasis on that. So, you know, you say, well, I'm an engineer, I'm required to do these things. And we've never required certification of any kind to be a software engineer, right? Anybody can say, I'm a software engineer, let me go build some code. I don't need to prove it, I don't need a degree, I don't need a certification or anything else. And that's kind of unique in engineering to software, right? I can't say, I'm going to call myself a civil engineer, I'm going to go out and build a bridge. Right? They don't let me do that. I need to get the certification. And I don't want to slow things down, so I'm not sure that I'm calling for certification of software engineers, but I want more accountability. And so some of that will come from government. I'm a little bit negative on the ability of government to do a good job, but I'm working on that. And one of the things I've done at Stanford is we had a boot camp on AI for congressional aides. And that was one reason to take off my .com Google hat and put on my .edu Stanford hat, because otherwise they wouldn't listen to me.
And they started before 2023 as well. It was 2019 that we started that boot camp. So again, a hipster moment for people.
And another thing is that I joined an AI safety group at Underwriters Laboratory. And I thought they were interesting because the last time there was a new technology the public thought was going to kill everybody. It was in 1900 or so when there was electricity, right? And everybody was worried about this new technology and how it was taking over the world and it was going to be deadly.
But didn't it kill a lot of people?
Well, Underwriters Laboratory stepped up and said, we're going to put a little sticker on your toaster that says, this is probably not going to kill you when you plug it in.
That's supposed to be for your home.
So now they're doing it for AI. They're trying to figure out what the role is. And I think there is a role for this. This is a third-party, non-profit, non-governmental organization, so they can kind of move faster than the government. And if the consumer finds that mark valuable, then the companies will say, well, we got to go ahead and get certified.
Is it fair to summarize that you're focusing your effort on the HAI front, both on education and kind of the private sector?
Yeah.
Okay.
Yeah.
That makes sense. Well, with those principles in mind, I want to get into the nitty-gritty as we kind of talked about earlier. Given we are among a lot of developers today, and you're very prolific on writing about programming, I love your blogs on them. How do you see the field of software development and programming change? And a scary question I'm going to seek there is, are AI going to replace software engineering as a function? Or I'll stop from there.
Right. So I guess that's like saying, is your IDE going to replace VI? Right? So if you're an old timer, you're used to just you type the code and that was it. Right? I'm old enough that they wanted me to use punch cards, and I refused to do that, and I still typed on a terminal. But you didn't have much support, and then you got more. And so I think that's where we are today with these AI tools. That no, you're not going to be replaced as a developer. If anything, there's going to be more developers. But the successful ones are going to be using these tools. And if you're not using the tools, you're going to fall behind. So don't worry, there's going to be plenty of jobs for you. One of the things I think is great is the ability of people to do more who aren't professional programmers, right? So I have a friend who's a scientist, a biologist. He tracks bird migrations and so on, and he said, I'm not a programmer. I didn't take any programming classes in college, but I learned how to read data from a spreadsheet and draw a plot and so on. And he said, but I always wanted to have like an interactive map where I could track these migrations and stuff, and I felt that was way beyond me. And then I saw this Copilot, and I started asking questions, and I built this app. And I never would have even tried without Copilot, because I knew a professional programmer could do it, but I could have never done it. And so I think we'll see more of that. So these end people, end users, being able to do more than they ever could before. But that means that you professional programmers should also be required to do more, right? You can get more done faster. You can get over the easy stuff. So I think that's going to be really exciting. To me, one of the things I'm really interested in is wondering, so yeah, the tools are going to get better, right? And there's going to be more, write me a program to do this, and it's going to get better at that. I think what's really interesting is saying, what language are we going to use to write that, right? So, I was around long enough to say when I started, we had programming languages that are really focused on the CPU, right? They said, how could we efficiently use these very slow cycles? And so we had assembler and then C, which were really focused on getting all the efficiency you could. And then we realized computers are getting cheaper and cheaper, programmers are getting more expensive, less optimized for the programmer, not for the computer, and we got languages like Python, which are fun to work with. And now, focus is not going to be on the hardware, not going to be on the programmer. It's going to be on this teamwork between the programmer and the language model. And we have to say, what's the right language for that? And it's probably not Python. It's probably something else. And one of you guys will help invent what that is.
You're exactly seeding the question. I want to get back to the language piece that we mentioned earlier. There's a lot of energy or idea around just making it feasible for folks to code in English. Do you see that feasible, or from what you're saying just now, it sounds like you do see the programming language being the connective tissue still, but maybe an evolved one?
Yeah. I think there'll be lots of different languages to use, and I think you can only get so far.
With programming language?
With programming language or with English, right? So English is great for a lot of things, but we had to invent language. We invented that, and it was good for what it's good at. But then we invented specific notations in math and physics and programming and everywhere else. And as those notations get better, we're able to do more. And I think we'll see more of that in this programming sphere. Right, so one of my hobbies is reading old math textbooks, right? And so you read Pascal or something, and he has this text, and it's all text, right? So there's no equations, and he's writing out and then the result will be proportional to the first part and inversely proportional to the second part. And reading that paragraph, you say, I'm completely lost. You say, wait a minute, let me write in the margin, P equals S over D times C over R. Okay, now I get it, right? Because this mathematical notation is so much more concise and understandable In the English, I got lost. And I think large language models will be exactly the same, right? If you try to only program in English, they get lost. But if you gave them, say, here's a great notation to use for this type of problem, then they can do better, right? So I think that's part of it. I think another part of it is, the way we use them now is we, for the most part, we ask one question and we get one answer. But that's not the way real creative work is done. Rather, it should be interactive. That you ask one thing, you go back and forth, you break it up into pieces, you evaluate what you've done, and go back and forth. And right now, each step in that loop, we're asking the human to step in and ask another prompt. But we should give these language models the ability to do that themselves, to make them be sort of a society of collaborating workers and break it up into sub-problems and go out and criticize the results and go back and forth.
Would you call that agentic or how?
Yeah, it's agentic, it's a society of minds, it's correcting from mistakes, it's iterative.
Gotcha. Well, with that existential question out of the way for the developers, as we kind of march to advance AI to make them more powerful, there's a lot of, you mentioned uncertainty or probability being kind of a breakthrough or transition point, and incomplete information is a big piece as well. Heck, for humans every day making decisions, those two pieces are big. For the next wave of advances, do you see overcoming those, what I see still being the key challenges from just scaling and so loosely model sizes that will get us further, or is there other pieces that you see coming in play?
Yeah, and I'm not sure I'm answering the question here, but I'll answer a different question.
That's fair, okay, go.
So one of the things I see is a confusion between problems and solutions, right? So people say things like, well, we want explainability in our models, and we don't like neural nets because they're not explainable. And we like, say, decision trees because they're simple. And to some extent that's true, and I'm sympathetic to that point of view. To another extent, you're saying, this is hard and we don't like the type of the solution, the neural net or whatever. And what you really meant was, well, the problem was inherently hard, and any solution will have that difficulty, right? It's just, there are things where we don't know the answer, or where, we're making prediction for the future and nobody can make a good prediction. And there's lots of areas where, you ask the experts in political judgment and they basically perform a chance. Or you look at judges making decisions, and now there's an automated system and it gets criticized by saying, well, look, here's some data in this automated system for deciding who should get parole is biased in the following ways. You say, well, that sounds bad. But look, the human judges are twice as biased. And we don't really know what the right answer is in these cases. And so, don't blame the messenger for the problem being the issue. And I think a lot of what we're seeing now is we're trying to solve problems that we never tried to solve before. So I had an example of this. This goes back about 10 years ago or so. So I'm on trip. I get an alert on my phone, and it says, time to return rental car to airport.
Is that a Google product?
With all Google products. So I said, this is awesome. Like somebody parsed my email from Avis, put in an entry in my calendar, gave the alert at the right time, even had parsed the address and had the right maps. Everything was awesome. And then they had to spoil it all by saying, time of travel, 20 minutes by bicycle.
It's the Google campus.
And on one hand, that was right, because I live about 20 minutes from the Google campus, and I ride my bike to work every day, so it had learned something about me, but it had not learned something about what it means to return a rental car. So, as a good
Carry it on
employee,
your bag.
I say, I'm going to file a bug report, and I get started, and there's a pull down that says, which team is responsible? And I said, wait a minute, everybody did their job perfectly, right? They parsed the email right, the map guys were right, everybody was right. And the only thing they missed was understanding how returning a rental car works. And yeah, they could put in a couple lines of code to do that. But if they were going to do that, there's 100,000 other things that are also at that level. And they got to put in a couple lines for that. So I'm asking them to do a 1 million line code change with this bug. And so I didn't file it. All right, I said, this is just not possible. Right? And so I said, aha, this is the difference between traditional programming and AI programming. In traditional programming, it's impossible to anticipate all those possible things of what disappointment could be and what the impact should be on whether you should take your bicycle. But in AI programming, you're expected to get that right. And it was just a couple months ago that for the first time, Bart got that right. I said, you know, I have to go to the airport, should I return my rental car, should I take my bike? And it finally said no. and up to then, and to this day, you know, ChatGPT still screws it up because they were over fine-tuned on safety. And so their answer is, whether you should take your bike depends on many factors, including the weather and traffic. I'd say, yeah, that's a good general answer, but that's not getting at this problem, right?
I see. You kind of touched on it a little bit. As we tackle all of these problems, to use your framing more, do you see it fruitful to do more narrow intelligence, so maybe more vertical, specialized applications? Some people are saying SLM, so small language model. Do you see that helpful to kind of nudge all of these smaller pieces from many directions?
Yeah, I think that's necessary. I think that's important. And you know, sometimes it's ironic. I wrote this article saying AGI is here, but only like 4 years ago, I was saying, I don't like these AGI researchers.
4 years ago, okay.
Yeah, I was saying, forget about AGI. We got a long way to go to build the components, right? I was saying, you know, that'd be like, you know, the Wright brothers saying, well, let's do artificial general flight. You know, let's build something that can fly to the moon and be a helicopter and be a 747. He said, no, you know, let's understand aerodynamics and build more jet engines and other components first. So a couple of years ago, I was an advocate for saying, let's have better components on which we can build these general things. And now I was wrong. And you can go a long way with the general part, but we could go even farther if we had better components to put into that general part. So I really support the continued work on that.
Are there specific components or domains that you see have the lowest friction and highest impact maybe that can be focused on to start?
I don't want to limit it, right?
Okay.
So I think everything's good, right? I guess the lowest friction is in language models because it's easiest to get the most data and it's not that computationally expensive. I think we'll see big advances in video in the coming years, right? So we saw over the last year still images. It was just kind of a little bit expensive to process videos, but that will get better because better chips will get built and better algorithms will come up for compressing and so on. So we'll be able to do more with video. And I think that's exciting because it just gives you a different view on the world, right? So anything that's written down is only written down because somebody thought it was worth writing down. And even with images, well, a lot of photos get taken these days, but most of them are kind of intentional in that, you know, I was focusing in this direction at this time and pressed the button at this time. And a lot of video is like that as well, but other video is just, I set up a camera and it's running 24/7. And it's just capturing the world without any intention, and so it gives you a much broader point of view. I think understanding that will help push us forward.
I'm kind of doubling down on the last question, but frame it differently. A lot of times the public awareness is behind on the AI research front. Arguably what Deep Blue could do, beating the world champion in chess, the model was there about like 2-3 years back. GPT was there before ChatGPT kind of blown us away. Is there anything similar in that sense that, hey, we are cooking this up, or we are very excited about these a few AI development concepts that you are excited about. We're not gonna hold you like to say, hey, that was wrong, but just what you're excited about right now.
So I guess, every decade we always say, well, robotics is coming soon. And it hasn't really happened yet. But I think there are signs that we're getting closer. And, as in general, AI, we kind of made the mistake of trying to do too much hand coding, and now the approaches are more based on using a lot of data. And so I think we'll see advances in that. And I think that'll be important, right? Because one of the criticisms you get of these language models is they're not embodied in the world, right? They're just stochastic parrots, or they're octopuses or something, because they haven't actually experienced the world. And I'm somewhat sympathetic to that. On the other hand, there are lots of people with limited interaction with the world, people that are blind or deaf or paraplegic and so on, and they have full internal lives and participate in the world. So to some extent, it doesn't rule it out. But being able to move around and touch things certainly could be a big advantage.
I want to move us into a quick fire round. First one, what's the top edit you want to add to your next edition for the textbook?
That's not a quick one.
name 5.
Right, so we had these large language models, but the whole process of what you should do to develop one, we have to do a better job of that. But the biggest one is, and this was true even in the 3rd edition, which was 2010, 11, something like that, and in the 4th edition in 2020. For each of those, I said, oh, phew, I'll never have to write a book again, because the next time there'll be this really cool interactive thing that will be easy to author. And that didn't happen
yet
in 2020. And if I was going to start writing now, I'm not completely convinced it would happen before I finished writing. So if any of you has a company to do that, I think that would be awesome.
Great, so education and making it more interactive, kind of, okay. If you have a magic wand, what would you want to be built by tomorrow?
I guess I would like to build a personal agent that will do the right thing for me, right? And you heard a little bit about one view of that this morning. So I want, it works great when I press the button on my phone and I pull up Uber or DoorDash or whatever, and I can interact with them. But then I've given up my privacy, and I know they do a pretty good job for me, but I know their number one customer is themselves. And
they told you to ride a bike, so that didn't work.
Yeah. So I'd rather say I want to have one app that I trust, that's an agent that I know is on my side, and let it go out and interact with everybody in the world.
Personal butler that understands, okay.
Well, it's more than just a personal butler. It's like, this is the way I'm going to interact, right? So I don't have 50 buttons on the home screen of my phone. I've got one button.
I see. How do you train your mind in your everyday life? Like, what do you maybe play to stay sharp, or the cognitive flexibility? Like, what's your diet?
Yeah, I feel like I'm really falling behind, right? That it's
impossible. You feel that way?
It's impossible to keep up. So funny thing, I was at the developers conference for Salesforce, and they had 2 young AI researchers and myself, and then an executive for Salesforce who really was not into AI and apparently did not read our bios very carefully. So he started with the other 2 and said, you're doing all these awesome things, which they certainly were. And then he turned to me and he said, oh, well you're at Google, your experience is search, so this AI stuff must be new to you, right? And so there was a laughter.
100% yes.
So he was embarrassed, and the other people on stage and in the audience helped to correct him. But I said, that's, you didn't quite get it right. But on the other hand, these two 25-year-olds sitting next to me, they do have an advantage over me in that they speak deep learning as their native language. And for me, it's my second language. And that's going to give me some advantages, is that I'm going to have some ways to compare what's going on now to what happened in the past, but it's also, it's always going to hold me back a little bit. And so I try my best to try to get around that.
I hear you. English is my second language, like pulling the two side of brains. For the audience, if we end on this, if you would suggest one skill, one topic, or even one book or movie for them to kind of get engaged, get interested as this crazy world of AI keep advancing, what would that be? Besides old math textbooks.
I guess the skill is don't get fixated, right? So it's okay to get stuck, but when you get stuck, just say, I'm going to approach it from a different point of view. And in terms of one book, every day you ask, it'll be different.
What's today?
So yesterday, I haven't read anything yet today.
Okay, okay, yesterday then.
Yesterday I was reading a book called The Mind is Flat. And its premise is we think we have this rich internal structure to our thoughts, but really what we're doing is we're just observing the world and reacting. And this ability to introspect and so on is just kind of built on top of that. So we're really, it's a kind of stimulus response is what we're built to do, and all this other stuff we just kind of trained on top of that. And so I think that's an interesting point of view to think about how people work and also think about how the machines we build work.
Kind of leave us back to that existential philosophical question of what is intelligence. But thank you so much. I think that's our time. That was awesome.